Good day, students. Sa ngayon, pag-usapan natin yung tungkol sa quantum numbers. Okay? Kung matatandaan nyo nung nakaraang linggo, we talk about the different models of the atom. At isa sa mga models na to, yung kay Niels Bohr. Okay? Tatandaan nyo ba yung ano niya? Yung kanyang model? So, yung model niya tungkol dun sa sa planetary model, 'di ba? So, kinumpara niya yung model ng atom doon um, sa solar system, saan yung sun, yun yung represent ng nucleus, and the planets are represented by the electrons moving around uh, the nucleus. Okay? So, there's what we call as the drawback in the Bohr's atomic model, no? Objections were made on Bohr's atomic model about the movement of electrons in 3D space and the spectra of polyelectronic atoms. So yun, yung kay Bohr kasi sabi niya 'di ba, nagmo-move yung mga electrons around the nucleus in what we call as orbits. Okay? Um in reality, it does not operate like that. So how these electrons are distributed and moving outside the nucleus still questionable during this time. So Bohr's atomic model failed to justify these objections. Okay, so in 1926, Rudolf Schrödinger gave the idea that of wave motion of electrons. Okay, so he was awarded the Nobel Prize in Physics in 1993. So he formulated an equation called the Schrödinger equation, in which electrons are treated as moving with wave-like motion in 3D space around the nucleus. So this solution of the Schrödinger equation gave a set of numerical values. Okay, so yun, si Erwin Schrödinger, siya yung nakapagpaliwanag kung paano ba talaga yung behavior nung mga electrons outside the nucleus. Okay? So, we came up with what we call as the quantum numbers. So, it explained the arrangement and the movement of electrons, spectral lines of polyelectronic atoms, and gave an acceptable model of an atom. So, these quantum numbers are essential in establishing the behavior of the electrons, as well as giving them some uh, information, no? Okay, so the four quantum numbers, okay, so merong apat na quantum numbers. Okay, these are what we call as, first we have the principal quantum number. Yung symbol niya is small letter n, so it specifies the main energy level or the orbit. Next, we have the azimuthal quantum number. That is the symbol lambda. Information about the sub-energy level. Okay, next, we have the magnetic quantum number, small letter m. Spatial orientations of an orbital. And then we have, this is spin. Okay? We have the spin quantum number. It specifies the spin movement of the electrons. Okay. So, ano yan eh. Okay, balikan lang natin. Itong apat na quantum numbers na to, para itong address. No? Address. It gives the address of the electron. So, yung principal quantum number, parang yan yung yung region. No? Kung saan nakatira kung saan included yung electron na yan. Saan ba yung region na yan? Pwedeng region natin, NCR, region 1, region 2, so on and so forth. So, yan. Parang ganun yung represent ng quantum number, yung region. And then we have the azimuthal quantum number. This represents the what you call the city. No? So, mayroong city. So, nakatira yung isang tao. Ganun din yung sa electron naman, katumbas na is the azimuthal quantum number. Next, we have the magnetic quantum number. The magnetic quantum number, ang katumbas naman niya is the straight, no? Straight. And then the spin quantum number, that is the house number. Okay? The house number ng specific electron. So if you combine all of these four, this will determine the address of the electron. Okay, so we have the principal quantum number, small letter n. It gives the size and energy of an orbit or shell. So, yung imaginary lines around the nucleus, that's what we call as a principal quantum number. So, your n could be 1, 2, 3, 4. So, yun yung values ng n. Okay? Next, you have a greater value of n represents bigger orbits with high energies. Okay? So, pag mas malaki yung value ng n, ibig sabihin, high energy yung mga electrons na nandun. Okay? Next, distance from the nucleus also increases. Okay? So, as you go away from the nucleus, the distance also increases. Next, there's what we call as the okay, so we have here the values. Okay, let's say the value is 1, 2, 3, 4. Okay, sometimes these principal quantum numbers are also represented by shells. Okay, so pwede rin siyang K, L, M, N. Next, we have the total number of electrons. So, how many number of electrons in each energy level? So, how are you going to determine that? So, are you going to use the formula 2n squared? Okay? So, let's take for example, energy level number 1. So, using the formula, we have 2. Okay? So, ilalagay mo na yung 1 because that is your n. Then, squared. So, 1 times 1 is 1. Okay? Multiplied by 2, that will give you 2. So, for first energy level, you have a maximum number of 2 electrons. Okay? So, what are the possibilities in the first energy level? Pwedeng 1 lang yung yung electron niya, or it could be 2. Okay? Pwedeng kulang, bawal sobra. So, hindi pwedeng maging 3 yung electrons doon sa first energy level. For the second energy level, we have we need to substitute 2, no? So 2 times 2, it will give you 4 times 2, that is equal to 8. So the maximum number of electrons in the second energy level is 8. Next, how about if the energy level is 3? Same process. Okay, 3 squared is equal to 9. Okay, times 2 is equal to 18. Okay, how about in the energy level number 4? So 4 squared is equal to 16 times 2, that will give you a maximum number of 32 electrons. So here are the total number of electrons in each energy level. Okay, just use the formula 2n squared. Next, we have azimuthal quantum number, lambda. Each energy level is divided into sublevels. Okay, so bawat energy level daw divided into sublevels. So, the azimuthal quantum number defines the shape of sub-energy level or orbital. Okay, so we have here azimuthal quantum number 0, 1, 2, 3. If you have, we have the sub-level S, P, D, F. Okay, so yung S, it means sharp. P is principal, D is diffuse, F is fundamental. Okay, so the number of electrons, if you are in the S sublevel, okay, you have 2. Okay, 2 for the S. For the P, we have 6 electrons. Okay, for D, we have 10. And F, we have 14. Okay, so yun yung total number of electrons per sublevel. So electron cloud, a cloud showing the probability of finding the electrons in terms of charge cloud around the nucleus. Okay, so electron cloud, dyan nandyan yung probability na makakahanap ka ng electron outside the nucleus. Okay, so yun, yung atomic orbitals, we have SPDF. Okay, so yun kanina yung sublevel, binabanggit din siyang sublevel, nabanggit din siyang atomic orbital. So yung mga SPDF na yan. Okay, these are regions of space wherein the probability of finding an electron about an atom is highest. Okay, so yung orbital na tinatawag, kung saan yung malaki yung chance mo na makakuha anong electron, no? Because electrons, remember, they move very fast. Okay, and you cannot pinpoint exactly where they are at a specific time. Okay, so we have S. The S orbital is spherically symmetric. Okay, so ganyan yung kanyang size. Okay, spherical. Okay, next for the P, it is dumbbell shape. So, ganyan yung itsura niya. At different orientation siya na. Next, you have D orbital. Okay, so ganyan yung itsura ni D. It's diffuse. And F, so dito may ano siya, may 4 lobes, no? Yung ating F orbital. Okay? So, pinakita ko lang yung itsura nila. So, relationship between N and azimuthal quantum number. So, okay, ito yung formula para ma-determine mo yung sublevel, no? So, your sublevel, your lambda, is equal to 0. Okay? If N is N minus 1. Okay? Okay, so tingnan natin dito yung orbit niya, no? Or yung energy level niya. KLMN. Okay, so your N is 1, 2, 3, 4, so on and so forth, no? So we have here the sublevel. Kapag energy level 1, the sublevel is equal to 0. Kapag 2, we have sublevel 0 and 1. Kapag 3, we have 0, 1, 2. And then 4 is equal to 0, 1, 2, 3. Okay? So, paano nangyari yun? So, N minus 1 lang. Okay? So, example, energy level 1. So, 1 minus 1 is equal to 0. Yun yung sublevel niya. Kapag 2 naman, energy level 2. So, we have 2 minus 1. So, 2 minus 1 is 1, right? So, yung 0 and 1, laging kasama yung 0 doon, ha. 0 and 1, these are the sublevels. Okay, kapag 3 naman, 3 minus 1 is 2. So, you have 0, 1, 2. Okay, same thing with energy level 4. For orbitals, energy level number 1, okay, we have 1s. Okay, so that means you have a total number of electrons or a maximum number of electrons of 2. Okay. And then for energy level number 2, we have 2s and 2p. Okay. So that will give you a total number of electrons of 8. 2 plus 6. So nagaling yung 2 para doon sa S sublevel. Okay. And then para sa yung 6 natin doon sa P. no, na orbital. So, yun. So, if you add that, that will give you 8, no? That 8 means that is the maximum number of electrons na pwedeng makita doon sa second energy level. Next, we have on the third energy level, the orbitals are 3s, 3p, and 3d. Okay, so we have 3s, okay, we have maximum of 2, and then we have 3p, that is 6, and then 3d, the maximum in d is 10. So, that is equal to 18. Okay, so the maximum number of electrons there is 18. And then we have the fourth energy level. We have 4s, 4p, 4d, 4f. If you total that, okay, 2 plus 6 plus 10 plus 14, that is equal to 32. Okay? So, 32 electrons. Okay, so pwede mo ring gamitin dito yung yung formula para sa energy level. Okay, so we have 2n squared. So para ma-determine mo yung number of electrons. Okay, so increasing energy and size. Okay, as you go deeper, the energy of the electrons increases as they move away from the nucleus, and of course the size actually of the, it's not the electron, no, but the or orbital, no, increases as you go away from the nucleus. Okay, so it means that the more dense an electron cloud is, the more electrons are found there. Okay, so yun yung tinutukoy natin na size. Next, we have the magnetic quantum number, or small letter m. It explains the effect of an orbital in magnetic field. That is the orientation of an orbital. Okay, so orbitals split up into degenerate orbitals. Pag sinabing degenerate, they have the same energy and size in a magnetic field. Okay, each degenerate orbital can hold up to 2 electrons. Okay, so yun yung total number of electrons that an orbital can hold. It's actually 2. Okay, so relationship between principal quantum number and magnetic quantum number. So m is equal to negative lambda. Okay, so magiging 0 and positive magnetic quantum number. Okay, so ayun, kapag yung sublevel mo ay 0, okay, so naging 0 yung sublevel, it means that yung energy level niyan is 1, right? So yung nandyan na orbital is S, so your M is equal also to 0. Okay, so yung magnetic quantum number mo is equal to 0. The generate orbitals is 1. Total of electrons there is 2. So yun yung explanation dyan sa sa 1. Okay, you have energy level number 2. Okay, so we have sublevel 1. Then we have P as the orbital. So we have negative 1, 0, positive 1. So yung tatandaan nyo dito pag sa magnetic quantum numbers, ano siya, yung values niya could range from negative m to positive m. Okay? So the generate orbitals is 3. Number of electrons is 6. Tandaan nyo, kapag S, dalawa lang yung maximum number of electrons. Kapag P, 6. Kapag D, 10. And then kapag F, 14. So, yun. Yung isa dito, sublevel is equal to 2. So that is D. Negative 2, negative 1, 0, positive 1, positive 2. Okay, so degenerate orbitals is 5. Maximum number of electrons is 10. Kapag 3 naman, that means na-reach na yung F orbital. So you have negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3. So you have orbitals is 7. Total number of electrons is 14. Okay, so ito same lang kanina, no? Mag-i-increase din yung size habang lumali. Okay, so we have spin quantum numbers. This is the fourth. Direction of spin of an electron. Electron which rotates around the nucleus also rotates around its own axis. This is self-rotation, either clockwise or anti-clockwise or counterclockwise. So S is ito yung mga values na S. It could be negative 1/2 or positive 1/2 for anti-clockwise. Negative 1/2 for clockwise. Okay, so yung spin quantum number, tandaan nyo yung ano yan eh. Yung electron, kahit na umiikot siya doon sa paligid ng nucleus, umiikot pa rin siya doon sa sarili niya, no? Parang Earth, di ba? May revolution yung Earth around the Sun. And then, habang nagre-revolve yung Earth doon sa Sun, it rotates. Okay? That's why we have day and night. Same logic also applies here in the electrons. Okay? So, yung electron, it spins on its own. Okay? While it moves around the nucleus. So, that's what we call as self-rotation. So, yung values niya could be negative 1/2 or positive 1/2. So, yun yung spin quantum number. Okay? So, yan. Spin of electron associated with magnetic field. So, yan. Associated siya sa magnetic field. Yung spin na yan. Okay, so, yun yung tungkol sa quantum numbers. Okay, so, yung quantum number siya yung address, no? Gives the address of an electron. Okay, salamat sa pakikinig.